Thank you very much, Luca. Thank you very much for the invitation. After the excellent lecture of Maria, I think that we may, let's say, start discussing about, several issues, and mainly, about the main challenges in the built environment. Which are the main challenges we have? First, we have a very important global and local climatic change. It's not just the increase of the temperature. It's much more than that, and we will discuss about it. Second, and you know it very well, we have a serious overpopulation. Third, we have poverty, especially in developing countries, but also, in developed countries. At the same time, we have a tremendous urbanization. In Europe, by 2050, about 90% of the population will live in cities. We have a problem of energy. We need to have sustainable energy provision. And at the same time, we have the big problem of the economic growth and the quality of life, as Maria, let's say, described it before. How all these problems affect the energy and environmental quality of the built environment or in the built environment? As I mentioned before, actually, we have a tremendous urbanization. Although, we had 6.5 billion people, we will have a total, let's say, population between 10 to 11 billion people. We expect to have 6.5 billion people living in cities. So we are living in cities, and we have to understand and really find the best way to meet together the need of cities with the need, of housing and the need of, let's say, the population. Which is the main parameter and the main challenge that affects the energy and environmental quality in the built environment? In my opinion, actually, the most important issue is overpopulation of cities. Overheating of cities. Is there a serious problem? Of course it's a very serious problem. According to the official data, there are 13,000 overheated cities around the world. There's 1.7 billion people living under severe overheating. Since the 80s, the number of overheating hours has increased by a factor of 3. So it is a very serious problem. And you will ask me, what is the impact of this overheating? There's a tremendous impact. First, it increases dramatically the energy consumption in the building sector. It increases the peak electricity demand because of the air conditioning, obliging utilities to build additional power plant to satisfy the demand. But these power plants may operate for some hours per year, and this increases the total cost of electricity. So we transfer the cost to the consumers. At the same time, it has a tremendous environmental impact. It increases dramatically the concentration of pollutants. Also, it increases, and we will discuss about it, in, very high levels, heat-related mortality and morbidity, and mental health. Also, it has a tremendous impact on productivity. And finally, it affects very much the survivability levels of low-income population. Do we have enough data to quantify the problem and the impact? Of course. During the last 10 years, 15 years, we have really all the proper values and all the proper, let's say, data to know, for example, that the, let's say, overheating of cities increase the energy consumption, close to 237 kilowatt hours per person in average. So every one of us is paying 240 kilowatt hours additional, because of the overheating of our cities. At the same time, we know, for example, that an increase of, let's say, the temperature by 1 degree decreases the efficiency of the power plants by 0.6%. So during a heat wave, when the temperature may increase up to 10 degrees, the efficiency of power plants is decreasing by 6%. 6% means a tremendous economic cost. At the same time, because of the overheating, per degree of temperature increase, the peak electricity demand, it increases up to 4.6%, which means that we need to build additional power plants. We need to have more, let's say, energy. But these power plants operate just for 5 days, 10 days per year. The cost of this operation of these power plants is tremendous. And this is transferred, to the consumers. And this is the main reason that the cost of electricity is increasing. Many people is asking, what is more important, the global climatic change or the regional climatic change, the overheating of cities? I have prepared an example just to demonstrate to you what really happens. And I use data from the city I'm living there, Sydney. During, let's say, the last years, or let's say in the 90s, the so-called cooling degree hours, which demonstrate, how much of cooling we need, in a central station close to, let's say, the coastal area, was 820. So what? By 2023, this year, in the same station, the number of cooling degree hours has increased, by 33%. Real data. This is the impact of the global climatic change, because this is a coastal station. We don't have overheating there. But once we move in the city, in the center of the city, the cooling degree hours have increased by 889, which is an increase by 81% in the center of the city. So there is a penalty on cooling close to 81% in Sydney, which is a very developed country, very developed city, because of the local overheating. But once we move to the very western part, where low-income population is living, the increase is really 300%. So, and these are real data, this is not simulation. So we impose a tremendous penalty to the population because of the overheating. And of course, the 300% is 10 times higher than the 30%. So regional climatic change, and especially, in big cities, is really much more important than the global climatic, change. A small detail. This 1.5 degree or 2 degrees, of global climatic, that increase of the global climatic change does not consider the increase of the temperature in cities. Does not take into account. Why? Because these calculations are based on the use of global climatic models. Global climatic models, they have a resolution of, about 100 kilometers by 100 kilometers. They cannot take into account cities. So the overheating of cities is not taken into account when we're discussing about 1.5 degrees or more. Anyway, does it have an economic cost? I give you just one specific, information. On August of 22, last year, the UK Met Office recorded the country's first even temperature above 40 degrees. And this was really a very high temperature increase. As a result of this, temperature increase, the power prices in the UK increased by 5%. 5%. Immediately, the same day. At the same time, in France, because, of the very high temperatures of the water in the rivers, there was a problem of cooling of the, nuclear power plants. As a result, the day-ahead base load power prices went up to 610 euros per megawatt hours, 10 times higher than the prices between 2015 and 2021. It's a tremendous economic cost. And these are real numbers. Apart of the energy impact, as I mentioned to you before, there is a very serious impact on, let's say, the environment, and especially on the concentration of the so-called ground level ozone. Ozone is a killer. 87% of the episodes of very high ozone concentration is because of the global overheating, of the local overheating. So it creates a tremendous problem, on the environmental quality of our cities. But it's not just that. We know that once the temperature is increasing by 1 degree, the pollutants emission by the power plants is increasing by about 3 to 3.5%. So imagine that during a heat wave with 10 degrees higher temperature, the emissions of pollutants by the power plants is 35% more. And then we're moving to a serious problem. Low-income population. We know that low-income population is living in non-proper housing. Non-well-insulated, non-well-protected housing. As a result, indoor temperatures are extremely high. And at the same time, they have to live, because they cannot afford to have air conditioning, they have to live under very high temperatures. And this has a tremendous impact on comfort, on health, on, let's say, productivity. Is it a serious problem? You may say that, of course, in emerging economies, it's a very serious problem. Is it a serious problem in Europe, for example? Yes. According to the European Parliament, only 2% of the necessary cooling load is covered by low-income population in Portugal. In Portugal, member of the European Union, only 2% of the needs. While another study showed that in Greece, the cost to cool a low-income housing is almost 2 times higher than the cost to cool, an average, let's say, house. So they pay a tremendous penalty because they are living in houses which are not really appropriate. Do we have enough data? Of course. We have monitored thousands of buildings around the world, trying to understand really what is happening in low-income houses. I'll show you some results. This is a monitoring of about 500 low-income houses in Athens during a heat wave. We started with indoor temperatures, average indoor temperatures of 26, 27. Fine, no problem. At the end of the heat wave, the average indoor temperature was 33, 34. But as you can see, most of the buildings, they had temperatures for more than 3 or 4 days above 40. When I moved to Australia, the Australian guys, they told me, and they are very good, and they protect the local people, They told me that we don't have energy poverty in Australia. Okay. We monitor, several low-income houses during a summer, but not during a heat wave. Indoor temperature, 40 degrees. For more than 2 days. But the worst is that because people is trying to be protected, they close everything. As a result, indoor pollution is extremely high. And indoor concentration of CO2 is 4 times higher than the threshold. So because of the overheating, people is living under very high indoor temperatures and very high, let's say, concentration of pollutants. Is it well documented? Yes. A very recent study in the United States trying really to understand the correlation and the relation between overheating and income, and this is done for the different, let's say, ethnic groups, shown, for example, that whites and high-income people, they are living in areas of, let's say, low temperature, while Hispanics and, black population is living in areas with much higher, overheating. So it's a social problem at the same time. It's not just, an environmental problem with tremendous economic, let's say, impact. And then we move to the most important impact that we may have because of the overheating, health. The relation between health mortality, morbidity, and temperature is not something linear. It depends on many, many parameters, and especially on demographic parameters, socioeconomic parameters, and the health infrastructure. In average, we know that in a city, the warmest areas or the warmest zones present 6% higher mortality than the coolest parts of the city. So there's a tremendous impact on health, in the overheated areas of cities. And what is the real impact of overheating in heat-related mortality? Depends on the structure and the infrastructure. For example, in developed countries with good infrastructure, it is close to 5%. Unfortunately, we don't have enough data from developing countries because they don't have the proper statistics. But data from, let's say, Brazil shows that during overheating, in Sao Paulo, for example, the increase of the heat-related mortality, or of the mortality, is 30%. 30%. And this creates a tremendous problem of cost. If you check really, for example, the cost, the monetized cost of, let's say, health problems caused by overheating in the United States, official reports from the United Nations government, the United States government, shows that the heat-related mortality cost was in 2021 144 billion. And this is, let's say, equivalent to the average income of 12.5 million people. So it's a tremendous cost on, let's say, health, which is caused by overheating. In France, recent data shows that between 2015 and 2019, the cost of just of heat-related mortality in the country was close to 25 to 26 billion, let's say, euros. So overheating has a tremendous cost on, let's say, health. But it's not just mortality. The biggest problem associating overheating with health is, let's say, mental health. You may not believe it. You may not really think about it. But if you see the statistics, for example, what is happening when temperature is increasing, there is a tremendous increase of murders and assault as a function of temperature. And this poses a tremendous problem, in the society. There is a very interesting study that has been performed recently in the United States, trying really to count the aggressive tweets into Twitter, as a function of temperature. Once the temperature is increasing, you see how the aggressivity of people is increasing. And this is a serious social problem. And of course, this is translated into an economic, let's say, impact and value. While, let's say, according to Lancet, the cost of mental health in 2010 was 2.5 trillion, the cost in 2030 will increase up to 6 trillion. So it is a tremendous cost. It's not some millions, trillions. A part of health, unfortunately, overheating affects human productivity. We know from physiological studies that productivity is affected by temperature. Studies involving millions of people and workers show that once temperature is increasing above 30 degrees, productivity may decrease up to 60–70%. A recent report in India during the heat wave, where temperature in Delhi for more than 4 or 5 days was higher than 50 degrees, shown that productivity of the outdoor workers has decreased by 90%. You understand the economic impact. And this, of course, will have a tremendous impact in the future because we expect much higher, let's say, increase of the temperature. So, just in the United States, I'm not talking about emerging economies, official data shows that the annual growth fails between 0.15 to 0.25% for every Fahrenheit increase of the summer temperature. It has a tremendous impact on economy. United States could lose approximately 100 billion annually from heat-induced loss in labor productivity. And of course, we understand what will happen in the developing countries. There will be a tremendous decrease of the GDP and the economic output because of the loss of productivity. If you see really the predictions for India, you will be terrified. These are the bad news. What about the future? What do we expect in the future in our cities? All models and all predictions shows that by 2030, 2050, the temperature in cities, and especially the minimum temperature, the nighttime temperature, may increase up to 5 or 7 degrees. If you don't believe me, see, for example, this, let's say, graph. It's not the same everywhere, but in the Middle East, you may have, let's say, an increase of the minimum temperature by 7 degrees, which means that the peak electricity demand is transferred during the night because we need air conditioning. And when it's transferred during the night, forget the photovoltaics if you don't have storage. So increases and give us a tremendous, let's say, energy problem. And also an important increase all around the world during the daytime. So in the future, we may have overheated cities, and the temperature may increase 3, 4, 5 degrees. The impact of this, let's say, important increase of the temperature, combined with the other parameters that we have, let's say, described before, will have a very serious impact on the energy consumption, and especially on, let's say, overpopulated countries, China. Official predictions show a tremendous increase of the energy consumption. India, Russia, Turkey. So we may have more energy needs, and it's a question which kind of energy is going to be used there, because, of the reasons that I just described you. And why we have such an increase of the energy consumption? Because of the overpopulation? Yes, in a way. The real reason behind the increase of the energy consumption is a tremendous increase of cooling. According to all the existing, let's say, forecasts, by 2050, and this is based on the economic development, on the rate of economic development, we may have an increase of the energy consumption for cooling, the minimum 1,300%, the maximum about, let's say, 3,000%. By 2050, the energy consumption for cooling, if we continue the same way, let's say, to build houses and developing cities, will increase by 3,000%. The energy consumption for cooling of a simple Indian city, Mumbai, will be higher than the total energy consumption of the United States. So you understand the impact on the energy balance of India. So the real problem, in the built environment, it has to do with, let's say, the overheating of cities. But it's not just an energy and environmental problem. It's not just an economic problem. It is also a social problem. For example, if you check today, or let's say tomorrow, the adoption of cooling in 4, let's say, countries, Brazil, Mexico, India, and Indonesia, you will see as a function, of the income groups. Here is the poorest, and here is, the more, let's say, wealthy population. You will see that there is a tremendous stratification regarding comfort conditions. I'm not talking about just penetration of cooling, comfort conditions. So, despite the very rapid penetration of air conditioning, in these 4 countries by 2040, there will be about 100 million households, about 3 to 400 million people, that they will not have any protection, no cooling at all. This will create a tremendous, given the overheating, a tremendous social problem there. And if you translate this into energy consumption, there will be a fantastic difference between the energy consumption of low-income population and high-income population. So overheating drives us to a very serious social problem. Bad news, bad news, bad news. Do we have good news? Yes, we have some good news. During the last 15, 20 years, there is a very serious research that has been carried out trying really to mitigate heat. And of course, I don't have the time to go through all the mitigation, let's say, techniques, but I like to refer to some very advanced, let's say, developments. And especially the development of new materials for the built environment, and especially to the so-called photonic materials. These materials present a very high reflectance, or supercool materials, and also the innovation is that they can send all the stored heat to the space directly. How? Through the atmospheric window. We can really send all the overheating stored in a material directly to the space, not to heat the atmosphere. Is it possible? Yes. We have developed these materials, which are now in the market, and these are the results we have for the testing we have performed, in the Australian desert, under the sun, 1000 watts, 38 degrees temperature. While the ambient temperature was, let's say, 30, 35 degrees, these materials had a surface temperature of 25, 26, 8 to 10 degrees below the ambient temperature, without the use of any energy. So it's a natural air conditioning. And this material... I'm sorry?
What is that material?
What is?
What is that material?
What do you mean?
You said that certain materials are invented that allow, that makes the surface temperature of that material cooler. What is that material? What is the invention?
What is the composition of these materials? Depends. Can be paints, for example. Can be metal materials. There are different forms of these materials. What is important to understand is that these materials, for example, a green or a red photonic material, maybe, and it is, you see the result, 4 degrees of lower temperature than a conventional white. So imagine a red surface, which is absorbing a lot, to be 4 degrees of lower temperature than the conventional white. So we have really some hopes from the new technological developments. So now we are able to decrease the temperature of cities up to, let's say, 2.5 degrees. We have 250 large-scale mitigation projects all around the world that we have succeeded to decrease the temperature of cities up to 2.5 degrees. With the development of the new technologies, we hope, and we have a tremendous new project now, we are coordinating in Saudi Arabia, in Riyadh, we will be able to decrease the temperature of cities by 4 or 5 degrees. This, a tremendous really potential, will have a huge impact on the quality of life. And you see, for example, the impact in Riyadh, which of course is decreasing the temperature by 4 or 5 degrees, but the most important, it decreases the energy demand of buildings in Riyadh by 35%, just by using, let's say, these materials in the built environment. The same study in Sydney shows that once really we implement these materials at the building scale, we may decrease the cooling demand by 29%. And when this is implemented at the urban scale, it can be, let's say, it can result in a decrease of the cooling demand by 50%. So the message is that we have technologies, we have the means to provide cooling without air conditioning. So the idea that put air conditioning everywhere to provide comfort is a very big mistake. And I will explain you why. First, before, let's say, analyzing the impact of the new technology, let's understand what really we plan for the future. Actually, there are more than 225 billion square meters of floor area will be built in emerging economies, Brazil, India, etc. There is a shortfall of about 330 million homes in the world, and this will increase to about 440 million by 2025. By 2030, the additional housing needs will grow by more than 77 billion square meters. In brief, we built a Paris per week. This is the construction level. We built a Paris per week. And the main question is, how we built? Business as usual? The Western, let's say, standards? Any other type of standards? Do we have to diversify the design according to the, let's say, the demand of people or the physiological, let's say, requirements? Allow me to tell you something. We don't need the same indoor conditions all around the world. Why? Because we don't have the same physiological adaptation all around the world. What does it mean that? Some examples. The optimum mortality temperature, which is the temperature where the mortality is the minimum in a country. It is in the northern of Europe between 17 to 19 degrees. In the south of Europe, it is 25 to 28. We don't behave the same. Second, if you don't, these are official data from the European Union. China. See the response of heat-related mortality as a function of temperature. In the northeastern of China, in the cold areas, the minimum mortality is at very low temperature, 17 degrees. At the south of China is 27.4. So we don't behave the same. And once this is translated into comfort conditions, according to the European, let's say, standards and the European knowledge, we don't behave the same way. For example, the comfort temperature in, let's say, the different European countries as a function of the outdoor temperature shows, for example, that in Greece can be, let's say, close to 30 degrees, while at the same time in the UK may be 22, 23. Why? Because, comfort is a function of adaptation. We learn to know, we learn to live in a place, and our body is adapted. What does it mean that? It means that we need to apply, and these are official comfort standards that really exist in the world, that shows that indoor comfort is a function of the outdoor temperature in the area. So someone which is living, for example, in a place with an average annual temperature close to, let's say, 17, 18 degrees, like here, needs a temperature close to 22, 23 degrees. But someone which is living with, let's say, in an area with a temperature close to 31, 32 degrees, the indoor temperature, the optimum indoor temperature, is 27, 28, 29. And this is official standard. So why really? Yes, please.
So can I ask a question that I find it quite fascinating? But I wonder whether this is something that you would consider, let's say, constant for every human. So let's say once I was growing up in Germany, if it becomes warmer, then I would still need a comfortable temperature of, let's say, 19 degrees. Or whether this is something that we can, as humans, just adapt. So if it becomes warmer in, let's say, German city, then the Germans will adapt. So there's, let's say, less need to still aim for these 19 degrees, but just have a higher comfortable temperature over time. So
physiological adaptation in a place may take, 50 to 60 years.
okay, yeah.
You can't do it immediately. Adaptation, is different in a country, and it has to do with, the history of the temperature of a human, let's say, being. So if you live in a place the last 23 years, 20 years, and you are living under specific temperatures, you are adapted to this temperature. if you are moving in a place, you will be adapted in 2 or 3 years, you know. It will take time to do that. So, how really the different physiological needs we have affect the energy consumption? This is a very interesting study from United States that shows that really the impact on the cooling demand as a function of the cooling set point. You see, for example, that once we decrease the temperature of the thermostat, like in Florida, 21 degrees everywhere. I was in Florida some days ago, and I let's say, complained in my hotel that the temperature was very low for me, 21 degrees, and they given me blankets. You know? Just check the increase of, let's say, of the energy savings as a function of the temperature. So you may decrease in United States the temperature, you know, the energy consumption by 50 or 60 degrees once really we are using the proper and correct physiological standards. How really we can achieve to decrease the energy consumption and adapt people to the specific physiological conditions? And which is the impact? Do we have the technologies? Yes. During the very last years, we have all these technologies, for example, the use of the materials I showed you before, that may protect the population with a minimum cost. For example, once these mitigation materials are implemented on the roof of buildings in Australia, and these are real data, we decrease the peak indoor temperature by 8 or 9 degrees. For example, in a school, during a heat wave, without, let's say, protection, you may have an indoor temperature of 35, 36 degrees. So usually the governments are coming and say air conditioning. It was a disaster to put air conditioning in a school, especially, you know, split units, because you don't have ventilation, and in this case you have a tremendous indoor pollution, and also you adapt the local population to very low temperatures. But once, you know, these technologies of, let's say, cool materials are implemented in the school, the decrease of the indoor temperature is close to 10 degrees. So you don't need to have air conditioning because you have better technologies to do that. On the other hand, development of new fan technologies, and these are data from Berkeley University, shows, for example, that it is possible by using proper fans, new technology of fans, to decrease the energy consumption by 33%. Also, we are able to build in the equator under very high temperatures zero cooling buildings. And this is the NUS, National University of Singapore, building of School of Architecture. Zero cooling in the equator. So from the technical point of view, we have the knowledge to build buildings, houses without any cooling. And this brings us to, let's say, the future. There's two scenarios. The gray scenario that we follow today, and the main, let's say, characteristics of this gray scenario is that in the emerging economies, we have a very low energy consumption. Why we have a low energy consumption? Because they don't really, let's say, satisfy their needs. They live under very high temperatures. They don't satisfy the needs. So the energy consumption is very low. And this, of course, results in about, let's say, 30% of the time in discomfort. But people is adapted to the current temperatures. The future, 2030, 2050. If we follow the same model as today, the gray scenario, there will be an increase of the energy requirement by 150%. Because, you know, people has really to improve their conditions because of the temperature increase, because of health reasons, and many more. However, although there will be an increase of the energy consumption by 150%, the discomfort rate will increase from 30 to 70%. At the same time, a very high part of the people will not be adapted to high temperatures. I showed you the low-income population in the 4 countries. There will be an increase of the heat-related mortality by 40%. And there will be an increase of the let's say, ground-level ozone, concentration of ozone, up to 70%. So we may have a tremendous increase of the energy consumption, but we will have, at the same time, much worse conditions, in the built environment. And which is really the solution? The gray scenario says that put air conditioning there. The air conditioning industry is pushing really to put air conditioning all around the world. The result, if we follow this scenario, the energy consumption in these countries will increase by 400%, the minimum, which means that they have to find the proper energy, they have to build the new power plants, they need really to pay for all these, let's say, new energy provisions. People living in the air-conditioned buildings will be adapted to low temperatures. We change the adaptation, the physiological, let's say, conditions of the the population in the emerging economies. This means that artificially, while they don't need it, we change, their physiological characteristics. They have to build tremendous big, let's say, new power stations. Heat from the air conditioning, because you have a tremendous implementation of air conditioning under the gray scenario, will further increase the temperature of cities up to 2 degrees, because we have, let's say, waste heat. For the low-income population, which cannot really afford the use of air conditioning, survivability levels will be very low. And at the same time, from the economic point of view, this scenario has not really any added value for the country. You import, the air conditioning, you import all the systems. Maria has explained it very much, that in order to be affordable, we need to have a very high added value. So this is a scenario that does not solve any problem. On the contrary, increases tremendously the energy consumption, increases the peak electricity demand, obliging really the countries to build and increase build their power plants and increase the, let's say, cost of electricity, increase heat-related mortality, increase the temperature of cities, and so on. It's not a solution. Do we have a green solution or a green ecosystem? Yes. If really the first priority is to improve the quality of our cities, because the problem is there. With 5 or 10 degrees higher urban temperature, the energy consumption of buildings is increasing tremendously. So we are able today, with the technology we have, to decrease, let's say, the peak temperature in cities up to 4 degrees. This means that the energy consumption will decrease or remain constant. Under the previous scenario, we had an increase by 150%. At the same time, the discomfort rate will decrease from 30% to 20%. People will be really adapted to the urban climatic conditions. We will have a decrease of the heat-related mortality by 30%, and we will have a decrease of the pollution by 20%. And once first we improve the quality of the cities, and then we improve the quality of buildings by using appropriate technologies, and not a simple, let's say, transformation or a simple, transfer of the Western air conditioning buildings to the emerging economies, but we are using appropriate technologies with high added value for the area, we will have an energy consumption up to 75%, because they need to increase the energy consumption, but not 400%, like in the previous scenario. At the same time, we may have this increase of the energy consumption because of the rebound effect. Once you offer better living conditions to people, they will increase the energy consumption. And the same happens, also in developing economies. But 75% is not 400%. So we can really improve the environmental conditions there without really having a serious problem of energy consumption. We will have a small increase of the peak electricity demand. We will have a decrease of the heat-related mortality. We will have, let's say, an improvement of the living conditions for the low-income population, and we will have a decrease of, let's say, the concentration of ozone. The cost. How to do that? According, to all the statistics and all the, the studies, the cost of decarbonization is 1.6 trillion American dollars. How much does it cost to decrease the temperature of cities? According to our calculations, it is close to, let's say, 500 to 700, 100 to 350 billions per year. Is too much? No. Because actually the cost of overheating in the global economy is between 500 to 700 billion American dollars, and this cost will go up to 1.3 trillions in 2050. So if we don't follow proactive agendas in the built environment, and especially cities, the cost will be tremendous. And if we follow reactive, let's say, policies in cities and in the built environment, we will have a tremendous cost without solving the problem. I like to finalize with, let's say, some thoughts on the way we can do it. In my opinion, the problem of better housing, the problem of better quality in the built environment is not a technological problem. We know how to do it. We can have zero energy buildings everywhere. We can have cities without overheating. The technological problem is almost solved. The problem is financial, is economic. This is the problem. So in reality, it's not enough in our agenda to change the way we design, to change the way we build and operate the urban buildings, to have better buildings. We know how to do it. Of course we have to do it. But at the same time, we have to combine with policies that put a value on the urban mitigation and adaptation capital that limits the stress of local climatic change and environmental quality. In reality, we have to monetize the cost of overheating. Someone has to pay for it. This is extremely important. How this can be done? I don't have the time to go into details. We can discuss if you want. But it is time that those that they increase the urban warming and they increase the pollution levels to pay. And those that they decrease the temperature of cities by using greenery, good materials, better materials, we know how to do it, they need to have credits. So I'm proposing to develop a system of, let's say, financial markets that those that they increase the temperature in cities, they pay, and those that they decrease the temperature in cities, they have credits. This will give the necessary incentives to developers, governments, etc., to develop, proper methodologies that solves the major problem of overheating. And this, of course, will have a tremendous impact on the economy, but also will have a very important impact on the quality of life of people. The most important, before my last slide, is that to do that, we need to work together. Actually, the built environment, let's say, research and knowledge and science, it is very fragmented. I'm an engineer, a physicist, there is an environmentalist, an epidemiologist, an economist, different, let's say, disciplines. We don't communicate. And what really Luca is doing is very important because it allows really to communicate. We don't communicate. So in reality, governments, they take decisions based on different groups. But we don't have holistic approaches in the built environment. So there is a need for an holistic approach in the built environment, holistic policies that take into account not only the technological issues, not only the financial issues, not only the environmental issues, not only the health issues, but take them all together. Once really this happens, I'm sure that by investing and counterbalances the urban climatic change, this may be the next productivity engine to drive growth. Thank you.